When we look up at the night sky, we can't help but wonder about the secrets of the sun and the planets. But not everything we've been told about the solar system is true. Today, we're going to uncover the 10 biggest myths you probably believe about our corner of the cosmos. Get ready, because what you're about to learn might change everything. It's easy to assume that Mercury, the closest planet to the Sun, must also be the hottest. After all, it orbits at an average distance of only 58 million kilometers, or 36 million miles from our star, and its daytime surface temperature can soar to 430 degrees Celsius. However, Mercury lacks an atmosphere capable of trapping heat, so when night falls, which lasts for 88 Earth days, its temperature plunges to a frigid minus 180 degrees Celsius. Now, let's talk about Venus. Venus is the second planet from the Sun, but its dense atmosphere, made up primarily of carbon dioxide, acts as a runaway greenhouse. This thick atmosphere traps solar heat so efficiently that Venus maintains a nearly uniform surface temperature of around 465 degrees Celsius, day and night. Its cloud layers even reflect much of the sun's light, but the heat it retains is enough to melt lead. Venus's greenhouse effect is so extreme that it far outpaces Mercury's scorching daytime highs. This makes Venus, not Mercury, the true hottest planet in the solar system. The term "dark side of the moon" has sparked countless misconceptions. Many people think it refers to a side of the moon that is perpetually hidden in darkness, but this isn't true. The moon is tidally locked to Earth, which means the same face always points toward us. However, this doesn't mean the far side of the moon is always dark. As the moon orbits Earth, sunlight illuminates different parts of its surface, just like Earth experiences day and night. A full cycle takes about 29.5 days, during which every part of the moon receives sunlight at some point. The term dark side is more poetic than scientific. It refers to the fact that the far side of the moon is hidden from our view, not that it's devoid of sunlight. In fact, the far side of the moon was first photographed in 1959 by the Soviet spacecraft Luna 3, showing a rugged and cratered landscape bathed in sunlight. Hollywood loves to depict the asteroid belt as a chaotic region where spacecraft must dodge a maze of tumbling rocks. While it makes for thrilling scenes, the reality is much less dramatic. The asteroid belt, located between Mars and Jupiter, is incredibly vast, spanning roughly 225 million kilometers in width. Within this enormous space, there are millions of asteroids, but they are spread out so widely that the average distance between them is about 1 million kilometers. In fact, if you were to fly a spacecraft through the asteroid belt, the odds of encountering a single asteroid are extremely low. Most asteroids are small, irregularly shaped rocks, and only a few, like Ceres and Vesta, are large enough to be classified as dwarf planets or protoplanets. The asteroid belt is more of a cosmic ghost town than a chaotic danger zone. This empty expanse highlights how vast and sparsely populated our solar system truly is. But don't be fooled. Asteroids are fascinating objects, remnants from the early solar system that hold clues to how planets like Earth formed billions of years ago. When people think of planetary rings, Saturn immediately comes to mind. Its stunning, bright rings make it the poster child of the solar system. However, Saturn is not the only planet with rings. It's just the one with the most prominent and photogenic ones. Jupiter, Uranus, and Neptune also have ring systems, but they are much less visible due to their faintness and composition. Jupiter's rings, discovered by the Voyager spacecraft in 1979, are made of fine dust particles, likely created by impacts on its small moons. Uranus rings are darker and denser, consisting of chunks of ice and rock that reflect very little light. Neptune's rings are similar but even fainter, with some incomplete arcs that puzzle scientists. Saturn's rings, on the other hand, are massive and primarily composed of water ice, mixed with smaller amounts of dust and rock. These rings stretch over 280,000 kilometers wide but are remarkably thin, only about 10 meters thick in most places. Saturn may have the most striking rings, but the truth is, ring systems are more common in the solar system than we once thought. Pluto's reclassification in 2006 sparked widespread confusion and controversy. When the International Astronomical Union (IAU) introduced a formal definition of a planet, Pluto didn't meet all the criteria. Specifically, while Pluto orbits the Sun and is spherical due to its gravity, it hasn't cleared its orbital path of other debris, an essential part of the IAU's definition. As a result, Pluto was reclassified as a dwarf planet. However, saying Pluto is no longer a planet oversimplifies the story. Dwarf planets, including Pluto, are still planets. They're just in a subcategory. Pluto remains an extraordinary object. Its surface features icy plains, towering mountains of water ice, and even a thin atmosphere that expands and contracts as it moves closer to or farther from the Sun. Moreover, Pluto's moon, Charon, is so large compared to Pluto that the two form a binary system, where both objects orbit a shared center of gravity. The New Horizons mission revealed Pluto to be far more complex and active than anyone imagined, proving that being a dwarf planet doesn't make it any less fascinating or important. It's a common misconception that the Sun is a gigantic fireball burning like a colossal bonfire in space. In reality, the Sun doesn't burn in the way we understand fire on Earth. Fire requires oxygen, but there's no oxygen in the Sun's core. Instead, the Sun generates energy through nuclear fusion, a process far more powerful and efficient than any chemical reaction. At the core of the Sun, temperatures reach about 15 million degrees Celsius, and pressures are so immense that hydrogen atoms collide and fuse to form helium. This process releases massive amounts of energy, which travels outward through the Sun's layers before radiating into space as light and heat. The Sun has been fusing hydrogen for about 4.6 billion years and has enough fuel to continue for another 5 billion years. Far from being a simple ball of fire, The Sun is a nuclear powerhouse that sustains life on Earth and drives the dynamics of the solar system. Understanding this process helps us better appreciate the immense forces at play in our star and the universe. Mars is often nicknamed the Red Planet, and for good reason. Its surface is coated with iron oxide, giving it a reddish hue that's visible even from Earth. But this nickname oversimplifies Mars' appearance. In reality, Mars is a planet of diverse colors and textures. Its iron-rich soil reflects shades of orange, brown, and yellow, while volcanic rock formations and impact craters add dark gray and black tones to the landscape. In certain regions, winds sculpt towering sand dunes with golden and even bluish hues, depending on the mineral content. During dust storms, which can encompass the entire planet, the sky takes on a rusty tint, temporarily amplifying Mars' red image. However, when the storms clear, the planet reveals a far more complex palette. The polar ice caps, made of water and carbon dioxide ice, shine white against the ruddy terrain, further breaking the monotony. Mars is not just a red desert. It's a vibrant, dynamic world. This diversity is crucial for scientists as they study its geology and search for signs of past or present life. Jupiter's immense size and composition, mostly hydrogen and helium, make it easy to see why some might label it a failed star. However, this description is misleading. While Jupiter is often compared to the Sun in terms of its elemental makeup, it never had the mass necessary to ignite nuclear fusion, the defining characteristic of a star. For a celestial body to become a star, its core temperature must reach tens of millions of degrees, which requires a mass about 75 times that of Jupiter. Jupiter simply isn't in the same league. Instead, it's classified as a gas giant, with its own fascinating characteristics. Its immense gravity has shaped its many moons, some of which, like Europa and Ganymede, might harbor conditions suitable for life. Furthermore, Jupiter's role in the solar system is critical. Its powerful gravitational field acts as a cosmic shield, deflecting asteroids and comets that might otherwise threaten the inner planets, including Earth. Far from being a failed anything, Jupiter is a cosmic success, playing a vital role in the stability and structure of our solar system. At first glance, Earth appears to be a perfectly round sphere, especially in images taken from space. But this is an illusion created by perspective. Earth's rotation causes a phenomenon called equatorial bulge, where centrifugal force pushes matter outward at the equator. This results in a slightly flattened shape at the poles and a bulging equator, making Earth an oblate spheroid rather than a perfect sphere. The difference in diameter isn't drastic, about 42 kilometers, but it has measurable effects. For example, gravity at the equator is slightly weaker than at the poles due to the increased distance from Earth's center. This equatorial bulge also affects ocean currents and atmospheric circulation, contributing to weather patterns and climate zones. Understanding Earth's shape isn't just academic. It's crucial for technologies like GPS, which require precise measurements of Earth's geometry to function accurately. Earth's imperfection is a defining feature of its dynamic nature as a rotating, living planet. Water is often thought of as a uniquely earthly resource, but it turns out that the universe is teeming with it. Water exists in various forms across the solar system, from ice to vapor, and even as liquid in certain environments. Europa, a moon of Jupiter, is a prime example. Beneath its thick crust of ice lies a vast subsurface ocean kept warm by tidal heating. Scientists estimate that this ocean could contain more water than all of Earth's oceans combined, making it one of the most promising locations to search for extraterrestrial life. Saturn's moon Enceladus also hides a subsurface ocean, evidenced by plumes of water vapor and organic molecules erupting from its surface. These geysers offer a glimpse into the potential habitability of its hidden ocean. Even distant dwarf planets like Ceres have been found to harbor water ice in their craters, and comets, essentially dirty snowballs, carry significant amounts of frozen water across the solar system. Beyond the solar system, water has been detected in the atmospheres of exoplanets and in molecular clouds that birth stars. Water is not just abundant. It's a fundamental building block of the cosmos, making the search for life beyond Earth even more exciting. The solar system is full of wonders, but it's also surrounded by myths. Now that you know the truth behind some of the biggest misconceptions, share this knowledge with your friends and keep exploring the marvels of the cosmos. The more we learn about the universe, the more it surprises us. Did you enjoy this video? Then give it a like, subscribe to the channel, and turn on notifications for more fascinating discoveries about the universe. See you next time.